Thanks for joining us. I'm Safrino. I'm a customer reliability engineer at Nobl9, and I'm joined today by Ian.
Hi, I'm Ian Bartholomew. I am the Site Reliability Engineering Manager here at Nobl9.
And today we're going to talk to you about, SLOs for Kubernetes, and more particularly how we use SLOs at Nobl9. So a little bit about Nobl9. We're an observability platform. We pull in metrics from several data sources you can see over here on the left. We then, work with customers to create an SLI. So that generally represents a query in which we would get a metric and that we then consume in our platform. In our platform, we then, take those metrics and we do error budget calculations on them. And we actually, provide recommendations and various actions that could take place. Once certain thresholds of error budget are burnt, or if we notice that error budget will be exhausted after a period of time. Something we generally like to coach people to do with SLOs, and it's evident in the literature of both the SRE book and Alex Hidalgo's Implementing Service Level Objectives, is to try to make an SLO and create an SLI that is impacted, that's based upon customer usage, something that a customer feels. And we like to twist that just a little bit for the session and talk about it, not as the customer of a service, but the user of a service. Because, not everything that uses a service is a human being. There are services that are dependent upon others in which you need to have certain expectations of performing a certain level of reliability. One case in point for that today, we're going to be talking about Kubernetes. A lot of teams have their infrastructure focused. They stand up the Kubernetes cluster, and it's not them who are using it, or not directly the customers themselves of the product, but more so their consumers internally in the organization. So, and that's something that SLOs do really well, is that they quantify, what expectations the consumer or the user of the service will have. And then it allows you to make some decisions. Do we have to focus on tech debt and paying down and being more reliable, or can we actually push out new features? There's several other trade-offs in which we could talk about in, how to manage your service. But, and thinking a little bit broadly, like, okay, hey, we have an SLO now. What do we do with it? There's lots of actions and alerts you could do. More traditionally, people create alerts to, like, let's say PagerDuty or ServiceNow, in which you want to actually page on call or something like that to get people aware of a decision. Sometimes you want to just send a message out to Slack, or, hey, move a Jira ticket out of the backlog and to be triaged. A good example of that would be, let's say, you have a product that's deployed mostly in, a region, let's call it region A. And you notice that, hey, we are getting traffic from other regions, but it's not enough yet to justify putting a new deployment in that region. You could set an SLO to measure that for you, and then set an action. Hey, once this error budget's exhausted, move this Jira ticket out of the backlog and to be triaged, because we know it's now affecting our user base. Our user base has grown so much that it is, effective there. And likewise as well, with SLOs, it's something that is really helpful to keep in mind, is that you're not overperforming. Your services aren't being more reliable than they need to be in order to help you either be competitive or that are over delivering on customers' expectations. So some more there. Moving on a little bit here, Ian's going to talk to you a little bit about some more core features of Nobl9.
Yeah, so the platform itself is broken up into a few different horizontals here, and different layers. The outermost kind of being the data intake layer. This is the layer of the platform where we gather the metrics and the data that are sent to us from the agents. The model that we have for gathering metrics is that of an agent. We have a Docker image that you can spin up in your environment. And we also, in addition to that, we also have direct agents that we ourselves host, so you don't have to worry about maintaining those. But regardless of the deployment, those agents will query the data source that you have configured it for, whether that's CloudWatch, New Relic, Datadog, BigQuery, whatever, all of the different data sources that Sal showed in the previous slide. It will query that source and then send that data to the Nobl9 platform for processing, which is where we get the next layer there for the calculation. All of that data that is queried by the agents is then processed by the platform. Error budgets are calculated for the appropriate time window. Also, all of the there's a number of different calculations that are handled depending on what kind of SLO and SLI you have configured. Like if that is a occurrence-based SLO versus a time window or time frame. And so we calculate all of that in the platform, calculate the error budget, and then with that data, we then present it, which takes us then to the next layer. Part of that presentation layer is we have to downsample that data because it's a lot, and then depending on like the view and the current window that you want to display it at, we have to have different resolutions. So we handle all of the downsampling of that data into a presentable format, both in the graphs that you would use for looking at the SLO, as well as for reports, where we have the capability of generating reports for kind of an executive summary or whatever, team review, whatever your use case is there. But we present that data or we downsample that data and process that data for you, to be able to present in a kind of a consumable way. One of the other important features of a SLO platform is being able to alert on different behaviors, because nobody wants to be sitting in front of a dashboard all day, watching the SLO do different things. That's about as fun as watching paint dry. So we do have alerting built into the platform, and that will alert on a couple different behaviors, like whether that is burn down, whether that is whether that it's exhausted error budget, or error budget remaining. We have different characteristics that we can alert on, and you have the capability to tune that for your specific use case. And so whatever way you want to alert on, you have that ability. And we also have a number of different integrations where you can send that alert to, whether that's OpsGenie, PagerDuty. We also have, we have a number of other integrations, as well as just a generic webhook. So if you have a webhook set up for a specific workflow, such as disabling a CI workflow or deployment, you have the capability to do that. Whatever you want that to be, you can set that up. Additionally, we have the ability to export the data gathered for your own processing, whether you want to drop it into a data lake, whether you want to take, do some hold on to it, whatever the use case is, you have the ability to do that. And so we can export that data to like S3 or Snowflake for your own use. And that can, that would be for all of your data. So, whatever you want to do for that, you can do, or you can it's yours to have.
Yeah, that's right. I've seen a lot of customers go through, and every organization has like a single pane of glass that sometimes people look at for reliability and just generally seeing, hey, how are we doing lately? So data export was created with that in mind. Moving on, I know we talked a lot about, hey, what is Nobl9 as a whole? And, now it's time to dig into a little bit about our architecture. You could see over here, we have operations and SRE, application leads, general people that are creating SLOs. They then create an SLO config that either happens via slow cuddle and our command line interface to create a YAML or through the GUI, which the GUI obviously is using our web app, and eventually it exports out to an API. Nobl9 then consumes those SLIs that were calculated in there from various data sources, whichever you specified, pulls in the data, throws it through a calculation engine, and actually puts in and develops the error budgets for the service and where they are and how much is burnt and so forth. The data then gets exported back out through the web app to talk about in terms of alerts or to updating our graphs and so forth for users to interact with. Now, I know this webinar we said we're going to be talking about Kubernetes-based SLO specifically, and I like to call it everything in this blue box here is ran on Kubernetes at Nobl9. And we're going to talk to you a little bit about some of the SLOs we've developed around some of these services over here.
Yeah, and one of the things that we want to convey here is how we are gathering gathering metrics that we are then using for monitoring the platform. Our services are instrumented in exposing a metrics endpoint that's the standard metrics endpoint for Prometheus. We have a Prometheus instance running within our cluster that is configured to scrape those services, as well as a standard metric server deployment. So it's scraping from that and then doing a remote write up to AWS managed Prometheus. That is what we are utilizing for our metrics there. We then have a Nobl9 agent that is querying that data source for all the different SLOs and sending that back into the platform for processing into the different services. So the takeaway here is we utilize Prometheus in cluster to then do a remote write to managed Prometheus, or Amazon managed Prometheus, which is the crux of our observability here.
Awesome. Thanks, Ian. So now tell me a little bit about, how we manage our Kubernetes clusters,
Yeah, I think one of the foundational ideas that we have is we don't want to just do hardware-based SLOs, and kind of mean by that it's like, what's the CPU, memory, that sort of monitoring, because SLOs are meant to be user-focused, as Sal was talking about previously, whether that's human, whether that's another service. So we're mostly concerned about what the expected behavior of the service is, and whether that matches what the expectation is. So just a service can have a high memory consumption, and that can be completely healthy. Like if it's a Java application, it'll probably take out as much memory as you can throw at it. That doesn't mean that isn't a degraded state or anything. It just means that that's the kind of footprint of that application. And so, it doesn't mean that you're going to have a negative user experience. And so that's why you want to have your SLOs focused on the user experience. If the user is having a degraded experience, that's when you need to be concerned, and that's when you need to burn error budget. But not necessarily if you have like a spiky CPU or a spiky memory or a high memory consumption. So we try and focus on service-based and application-based SLOs, as well as on the platform itself, on the Kubernetes platform. There are some characteristics within the platform we can monitor for that will alert us to unwanted behavior within the platform itself. This is kind of our foundational idea and how we do things. What we in presenting a lot of the architecture that we just did, we're not just trying to talk about Nobl9 itself, but we're trying to explain what our platform looks like, what the contours of our platform is, because these also always depend. That's the inside joke that we have, or at least the running joke that we have is, it always depends. And so your SLOs are going to be specific to you and what your platform is. And so as we're presenting this is how we use Kubernetes. There are some kind of standard out of the box things that you could take away from that, but this is how we do it, and this is the contour and what our platform looks like.
So let's dive in a little bit more about SLOs in which Nobl9 has picked. I know like we have some examples around container restarts and terminated and valid jobs. Can we get a sneak peek of what those look like?
Yeah, let me share my screen here. So one of the first ones that we'll talk about here is just container restarts. If there is a container that is hitting a limit of some sort and having to restart, that's what this SLO is looking at. We actually luckily had a incident. These are, and I should also point out, these are our production SLOs. So this is you're looking at the real deal here. So we did have excuse me. So we did have an incident yesterday, and you can see here we were able to annotate it. We had a new service rollout, and the limits weren't quite tuned, and so it was doing a bunch of restarts until we were able to raise those limits. And you can see here we burned down or burned a bunch of error budget, and we are now recovering. The this kind of generic platform level SLO is handy because we were able to notice that and see the issue that came out of that, or the issue that was happening. Take a look at the cluster and say like, oh, this new service, it's hitting our memory limit. We need to increase that. And so we have we were luckily able to use this for an actual incident yesterday. So we also have a 7-day container restart SLO. That is just the time window for this one is 7 days versus the last one, which was 24 hours. And you can see here, we do have that expressed here. The reason why we have the two is that we are kind of seeing which one is more meaningful for us. With the 7-day, we'll still have the dip. It's a little bit less pronounced than the 24-hour. And we have to have a higher level of reliability than we did for the 24-hour for this, a somewhat same number of minutes here. But the recovery of the burn down here is going to be slower. So
what you're trying to say is like, hey, you're spreading out your error budget from, a single day, which it's much more sensitive to the here and now, and through a 7-day window, even though it's the same exact SLI, when you expand your time window out, you're able to absorb more error budget over time.
Exactly.
So how would your team leverage, the 24-hour one versus the 7 days? Like, what different actions or decisions would the team make?
I think, we might have, we would be able to, or we'd have more time in the red here, potentially, depending on how long this lasted. And so, like, whatever kind of consequences we had set up for the team would be longer lived We might, so for the 24-hour, we might want that because, it'll be an easy fix. Oop, that's 7-day again. It might be a quick fix, but then we, quickly recover. And so again, whatever consequences we have set up, we would be able to get out of that as quickly, or more quicker. So again, this is something we're working with our teams to see how how it works out.
So,
and so for the
from what I'm understanding, it sounds like the 24-hour one, the team uses more so when you're in the thick of it. If you want to know, like, hey, we're actively in a situation where we need to resolve the incident, more sensitive to the different motions you could do to try to rectify it, versus in a 7-day, it's kind of more like your generic, hey, how am I doing this week? What decisions do we need to make as a team to actually go forth and fix our reliability?
Yeah, and I think the sensitive part is key here. Is that yes, this is going to be much more sensitive for both incident and remediation. So you'll be able to better gauge your solutions. So moving on, we also have containers terminated is another interesting one that we have. That's just one where the containers are just exiting without restarting. Here we also had that incident right here too, but you can see it has a different contour than the restarts, because this is just counting the terminations. This would be inclusive of cron jobs exiting. This is another one we just kind of have a little bit as a backstop to make sure that if there's any adverse behavior going on, that we're kind of keeping an eye on it. And you can see that it has a good amount of burn, a healthy amount of burn. We could probably tighten this up a little bit more, bring it up, and be able to have a healthy amount of burn and behavior in there. So I think this would be a good candidate to take a look at. Where we want to put our reliability.
So I notice here in this one, you have 2 different objectives and you have them codified here as good and okay. How does the team use these in making decisions?
The good is one that we had put into place as I think this is an all right amount. But we don't want to really kind of go over that. And the okay being okay, realistically, we're looking at this and they're all going to be around 8. And so we do want to, again, have a healthy amount of burn and to be able to show that we're utilizing all of the reliability. And so I think that probably we would, as part of the iteration process, we'll probably just change this to just be the 7, because that's the more realistic one that kind of has a good level of kind of pressure that we can put on it for higher reliability.
I like the, iteration the teams is doing here where, hey, we're taking a couple guesses of where we need to be, letting it bake in and see, hey, how do our expectations meet reality, and to be able to, justify something in between and saying, hey, what's reasonable, what makes sense, how we're going to have some errors, how much can we tolerate, and that's kind of, the whole idea behind SLOs.
Yeah, and we want to be able to have that kind of healthy amount of pressure for high reliability and natural burn, so that it also is a little bit to go back to the word sensitive. It is more sensitive to changes, and that we can better key off of and alert off of through the natural course of the service. One last one that we have is just failed jobs. This one tracks the number of failed jobs that we have. Luckily, it's been flat, so it's not terribly interesting. but this tracks all of the cron jobs that we have that have failed.
So, Ian, I remember reading in the SLO book that, error budgets are meant to be spent. This one's being, kind of flat right now. Is there anything the team would do to, try to burn some error budget? Any experimentations that they would want to do here?
Yeah, I mean, I think with this one, we can, depending on what kind of cron jobs we have, we can take a look at changing up or adding additional jobs to this. We could also just look at increasing the reliability. Right now we're at 99.9. We could increase that a little bit more to try and make this even more reliable and again more sensitive. So we can tighten that up and look at different cron cadences, maybe adding new ones. So there's a lot of different things we can do here.
So I also remember reading from the literature that generally you want to measure, a success over total because it's hard to define, failure modes at times. Why did the team choose to create a failed jobs one instead of successful jobs SLO?
With this particular one, it was difficult to get a total number of jobs, or at least reliably get a number of total jobs. So we weren't able to say these are all the successful ones. The signal for failed is a much stronger one, and so we went with that, even knowing that yes, we want it to be the successful ones. It's just the way that the query works out. It's much easier, much more reliable to do failed.
So you're accepting that, hey, accepting is the wrong word. You're trusting the signal you're getting. When you say a job has failed, you believe it, and you can rely upon that.
Yeah, and that's because of the exit statuses for the jobs, like the way that we query for them. Just getting the total number of attempted jobs is a little bit of a dubious math, and we kind of we found that the failed jobs was a little bit more reliable.
Fair enough. And that's something that people sometimes struggle with at times is writing an SLI. And sometimes, you're not able to get it perfect according to how the book or some people in a webinar tell you how it should be, but sometimes you have to go and make a judgment call for what is actually measurable. What do we trust in getting the signal there to actually provide the value we need to our organization?
Yeah. And I think on that note, I know we said no hardware SLOs, but we do have a couple of CPU and memory SLOs, and they are remarkably unremarkable, as you would kind of expect. And for here that for this one, it's the CPU request, and you can see that we have just a little bit of a little blip. And this is not going to necessarily be that meaningful, except as kind of a backstop. And we have this in place because SLOs are meant to express that things are not perfect, they're unreliable, and we expect them to be unreliable. We're kind of carrying this over to the creation of SLOs. So we're on our the continuous journey of observability and SLOs, and we want and we know that we're not perfect yet, and so we have this kind of as a backstop of, okay, did something go completely sideways into that in the cluster? We want to, is there a use case or a scenario that we didn't take into consideration? And so we want to have this just in case something goes completely sideways. There's a few other kind of backstops we could put in there, but I think this is probably a good canary in the coal mine for any sort of issue that might kind of pop up that we can that we wouldn't have already had an SLO on. We have, in addition to the ones you're seeing here, we have an extensive number of SLOs for our own services, for how things should operate. So we do have those in place, but these are just the Kubernetes specific SLOs, and this is the kind of that backs up for those.
Awesome. Thanks, Ian. I could take it over for you.
All right.
All right. And so with that, let's talk about some next steps. If you liked what you saw today, please feel free to sign up for a free trial of Nobl9, and feel free to email us at hello@Nobl9 if you have any questions about this. We're going to answer some in the webinar today, but if you're watching this a bit async, you still have questions, feel free to reach out, to and email us at hello@Nobl9.com, and we'll give you some expert advice where we can. We also like to always encourage people to get involved. If you like what you heard about iterating on SLOs, feel free to check out slowdlc.com and the community as well, and get involved and talk to people about what you heard. If you want to just generally be involved in slow conversation, just join the SlowConf Slack channel over here. And if you're going to be attending reInvent, feel free to book a meeting with us. All these QR codes, I believe, are live and should bring you to exactly where you need to be if you'd like to get involved. And I'll leave these on the screen for just a moment longer in case someone's got to fumble to unlock their phone or something and take a picture of it or whatnot. Okay, now we're gonna open it up to Q&A to questions. And it looks like we got a couple questions in the chat already. First question is from Corey. I'm curious about container restarts. Is that an SLO that users care about?
Yes. Well, yes and no. I think, if the service is still working, the restarts shouldn't necessarily matter. But so in this case, again, this is kind of a foundational piece that we're looking at. And this like for what happened to us just the other day. The service wasn't actually working, and we're still working on the SLOs for that particular service. And so we wouldn't have noticed that it wasn't up unless we had this foundational piece in there. I think that it is the user of that service would not have necessarily been able to interact with it because it was ohming all the time. It was just a crash, we'd back off and it was ohming. So we wouldn't have been able, so we weren't able to actually interact with or communicate with it. So yes, in this particular case, yes, it is one that the users would care about because they're not able to use the service.
So, but I think it's also important to have a general idea of your Kubernetes infrastructure. The engineering teams that have, their products running that they were created on that infrastructure, they're kind of almost your team's users in a way, it's some matter of fact as well, right? So making sure that their environments are healthy and active is also part of that.
Mm-hmm.
Moving on, Corey also followed up and asked, what are the SLI data sources used in these examples? I'm going to flip back to the slide we had here. Ian, do you want to take this one?
Yeah, for this particular one, it was the metric server. It's just out of the box, like nothing too special here. Just the standard metric server installation
that we then were able to comb with Prometheus and export to AWS Managed Prometheus, correct?
Yep. Yeah. So what the agent itself was actually hitting the Managed Prometheus. So that's the actual data source, but the source, the source of the source is the metric server that we're using, and then the in-cluster Prometheus is scraping and sending up to Amazon Managed Prometheus.
What's the best recommended way to document what the SLO is measuring or trying to achieve. Something I'd recommend here is SLO DLC. This is a whole community around the development of SLOs, and there's a whole handbook here with tons of instructions on how to help people along in their SLO journey. And we even provide tons of templates here, that you can go off and use. I'm just gonna pick the design worksheet here. Oh, let's go back. And in this template, you could actually go off and see, like, oh, hey, what's the service name? What's the team? Okay. All right. Thanks, Word. Where are the collaborators? And then you could also say some specifications. Hey, this is what it's called. This is what we want to do with it. Here's where it's deployed. Here are some objectives we want, alerting policies, and so forth. There are tons of templates, and these templates are available in, Markdown for you to use as well. So you can go off and, specify, hey, this is what we're trying to achieve with this. Here's what we think is reasonable. And over time, as you just change and adjust them, you could update them. Think of it as, documentation for your reliability, for your observability, and what you need to track and measure, and why you're making the changes you can over time. In an ideal world with Nobl9, all those pure metrics and queries and alerting policies and thresholds and all that live in YAML, but it's also nice to have a lot of the why and how you came to those decisions documented in accompanying Markdown that could live side by side, not only your SLO definitions, but also your code. And it's a great way to, track and version them as well as you're making changes and deploying out new features and so forth. A story I could think of is, oh, hey, we're making change to service A, but, we're accepting it being more unreliable, lowering your SLOs accordingly.
And also, what I'll add, once you get that documentation and everything in place, I'll show you one thing that you can do with that. And I'm going to share my screen again. So here in the detail view of the SLO, if we edit this and we go down to here, you can also add a link to that documentation that you've just created with the SLO DLC. We can say, like, let's say foobar, and it lives at https foobar.com. If you want to add additional description to that or for that, you can do that and say, like, my cool. And so giving more information there, which will then show up here on the detail view for the SLO. So you have, like, the description up here that will say, like, maybe what this is measuring, and then you can link to that document that Sal's talking about.
Awesome. And Ian, I think you should keep sharing your screen here a little bit. Nicolay is asking us, what SLO alerts are you using? Are they based on burn rates or exhausted budget?
One second. Yes, let me share my screen. So right now for us, what we are doing is, where did that go?
5.
Yeah. Actually, for this one, I didn't have it set up. That one is that one. But for this one, where did that go? Why is that one not set up? Sorry, hold on. We're doing it live, folks.
It wouldn't be a live demo without.
There we go. Yeah. So here we have two different policies: the fast burn and our slow burn. So for this particular, or most of these, we're using a slow burn and as kind of a warning, and then a fast burn for our alerts. Both of these or I'll have an annotation that gets thrown in, and then also a Slack notification for us. Some of these we have set up for pager duty for some of the more important ones, but those are more on application level. For these kind of the foundational ones, we have Slack, and then this is monitored by our on-call.
Great, thanks, Ian. I'm gonna say that one's answered. Corey's asking, what's the feature parity between the CLI and the Terraform provider? A great question, Corey. So our CLI is mostly up to date with our UI. It's only slightly behind in the new feature we released, replay, but that should be out soon in terms of getting complete parity there. Our Terraform provider is a little bit behind there, I'd say, a few versions, but our dev team is actively working on improving that to have one-to-one feature parity with our slow cuddle command line interface and with our UI. So if you're a Terraform user of Nobl9 right now, it still works. It's all right. And Ian was actually key in instrumenting and putting together a Terraform provider there. But it's just a little bit behind. We're going to polish that up over time and catch up.
I would say, like, for right now, that the Terraform provider is still, and the CLI are still very, very much usable. Like even though like might be a couple like detailed or small things, like Sal called out the replay functionality with the CLI is still completely usable. The Terraform provider right now is very stable and very usable. So I wouldn't worry about any critical features missing there.
I work with customers, and I know one customer that has nearly 2,000 SLOs all deployed and managed via the command line interface slow cuddle. And I have a couple other customers that are more in like the 300 to 600 range SLOs that are using Terraform provider there. So, these are definitely, when we say, hey, there might be a couple of little things here or there, they're still very much usable. People are still getting a lot of value out of the tools today. It's just, oh, hey, this one doesn't have the flame decals on the side of the door. We're still working on that bit.
Sal, I want flame decals on my Terraform provider.
It goes faster, right? With the sticker. Cool. So I think we answered everything in the Q&A and everything in chat.